Here we have to integrate the term e raised to the power of 9x minus 2 with respect to x. So we can integrate this using the method of substitution. So I'm going to put 9x minus 2 and this equals u. So basically we are using the u substitution. Now I take differentials on both sides, so therefore this implies 9 times of dx and this equals du. So let's find the dx from this equation, that is dx equals, we divide both sides by 9, we then get dx equals du over 9. So using this substitution as well as we can rewrite this dx as du by 9. We are going to convert this integral everything in terms of u variable. So I can rewrite this integral after the substitution. That is, this will become e raised to the power of this 9x minus 2. This will become u. So I'm going to put this as u. And then this dx will become du over 9. So I'm going to replace dx as du over 9. So now we have converted this given integral in x to u variable. Now I can factor this 1 by 9 out of the integral because it is a constant, and then integrate only the expression e power u. We know the standard integration formula, that is if we integrate e raised to the power of x, this is equal to e raised to the power of x plus the integration constant c. So we can utilize this integration formula. This is with respect to u. So it is similar to the formula. I'm going to put 1 by 9 times of integration of e power u is e power u plus the integration constant is c. So now we do the back substitution for u. That is, u can be replaced as 9x minus 2. So therefore this becomes 1 by 9 times of e raised to the power of 9x minus 2 plus c. So this is the result of the given integration. Let's do question 2. So here we have to integrate the term 6 times of cos x, cos of 2x. So once again we can integrate this using substitution method. So I'm going to put 2x equals, let's say that the variable now is t. So I'm going to take differentials on both sides. So this becomes 2 times of dx and this equals dt. From this I can find dx equals dt over 2. So let's convert this integral into two variable, since we have utilized the substitution 2x equal to t. So therefore this becomes, I put the 6 as it is, and then cos of, instead of 2x I can put t. So this becomes cos of t, and in place of dx I can replace this dx as dt over 2. So let me do that. So this becomes dt over 2. Now we cancel the 6 with the 2 as 3 times and factor out the 3 before the integral, since it is a constant, and we have to integrate only the term cos t with respect to t, that is dt. Now we can use the standard formula, that is integration of cos x dx. This is equal to sine x plus the integration constant c. So when we use this formula, we write down this result of this integral as 3 times of sine t plus the integration constant c. And we do the substitution, or we back substitute the t, that is t equals 2x. So therefore this becomes 3 times of sine of 2x plus c. So this is the result of the given integral. We will now determine the result of this given integral. That is, we have to integrate dx over under the root of 81 minus x squared. So here I'm going to put x equals 9 sine theta. This is a substitution I'm going to make. Now I take differentials on both sides. So differentials of x is dx, and when you differentiate sine theta with respect to theta, we get cos theta and then d theta. And I'm also going to square this equation both sides. So this becomes x squared equals 9 squared is 81, and square of sine theta is sine squared theta. Now we will rewrite this integral using this substitution that we just made. So I'm going to replace the dx as 9 times of cos theta d theta. Therefore, this will become dx is 9 cos theta d theta, and then divided by, this is under the root of 81 minus of x squared. X squared is 81 sine squared theta. We will simplify this. So this equals, we have 9 cos theta d theta in the numerator, and in the denominator we can see that we factor this 81 from these two terms. So I'm going to factor 81. When I do that, I get 1 minus of sine squared theta, and the whole term is under the root. We have to integrate this. Now, using the Pythagorean identity, we know that the Pythagorean trigonometric identity is sine squared theta plus cos squared theta equals 1. When I subtract sine squared theta on both sides, I get cos squared theta equals 1 minus of sine squared theta. Basically, the it is like an identity, that is 1 minus sine squared theta is identical to cos squared theta. So we are going to replace this 1 minus sine squared theta as cos squared theta in the next step. So let's simplify this. So this becomes 9 times of cos theta d theta over under the root of 81 times of, we replace 1 minus sine square theta as cos square theta. So therefore this becomes 81 cos square theta. And now let's simplify this further. So we have 9 cos theta d theta in the numerator, and this denominator expression under the root, this can be written as a product of two square roots, that is square root of 81 times of square root of cos square theta. So this equals, we know that square root of 81 is 9. So I rewrite this numerator term, that is 9 cos theta divided by square root of 81 is 9, and square root of cos square theta is cos theta. So basically we get the same term both in the numerator as well as this denominator, which means we can cancel these terms. 9 cancels with 9, cos theta cancels with cos theta. So therefore we are left with just integral of d theta. So this is basically equal to 1 times of d theta, and we know that integral of 1 dx, this equals x plus the integration constant c. So similarly, if you integrate 1 d theta, we just have to put the variable, that is the variable here is theta plus c. Uh, we cannot leave it with theta since we made this substitution in the beginning. So we have to find the theta from this expression, that is which is the substitution that we made. So let me copy the substitution which we made here. That is, we put x equals 9 sine theta. From this we have to determine the value of theta. So first let me divide both sides by 9. When I do that, I get x over 9 and 9 over 9. These two will get cancelled. So we get x over 9. This equals sine theta. Now we take sine inverse on both sides so that we determine the value of theta. So therefore this implies theta equals sine inverse of x over 9. Or we can write down this as arc sine x over 9. Both forms are accepted. So this is the value of theta. So that means we can replace this result as in terms of x as sine inverse of x over 9 plus the integration constant c, or also can be written as arc sine x over 9 plus c. So this is the result of this given integral. Let's integrate this expression. That is, we have to integrate sine of 3x plus e raised to the power of 2x plus 1 dx. So first I'm going to rewrite this as integral of 2, that is two terms, that is we have to integrate sine of 3x. I put this dx, plus we will also have to integrate e raised to the power of 2x plus 1 dx. So it's basically we are going to integrate these two terms separately. So I'm going to use substitution method to integrate both the terms. So here I'm going to put 3x equals u, and then if I take the differentials, I get 3 times of dx equals du, and this implies we can solve for dx, that is dx equals du over 3. And to integrate this second term, I'm going to put the substitution 2x plus 1. This equals, I can use another variable, that is t. Now I take the differentials on both sides, so therefore this becomes 2 times of dx equals dt, which means we can solve for dx from this. So dx equals dt over 2. So let's use this corresponding substitution for both integrals. So first let's do that. So let me complete it over here. So we will have to convert this integral in terms of u and this integral in terms of t, and then we have to integrate them. So therefore the first integral becomes sine of 3x. 3x is replaced as u, so it becomes sine of u, and then dx is replaced as du over 3. So it becomes like this, plus the second integral is e raised to the power of 2x plus 1. We already made the substitution 2x plus 1 equals t. So therefore this integral will get converted as e raised to the power of u, and then dx is replaced as, I'm sorry, this is, we have used another variable t. So this is e raised to the power of t times of dt over 2. Now we can integrate both the terms. So here I'm going to factor this 1/3, which is a constant, out of the integral, and we have to integrate only sine u over here. And similarly, I can factor the 1/2 over here, and then integrate only the e raised to the power of t. Then we have this dt. So using the standard integration formula, we know that integral of sine u, this will be negative cos u. And I can put this integration constant, just one integration constant after I integrate this. So I put plus half of, using the standard integration formula, we know that integration of e raised to the power of uh, the term will be e raised to the power of the same variable, that is e raised to the power of t, plus now I put the integration constant for both integrals, that is I put this one constant c. Now we have to do the back substitution for the corresponding variables. So this will become negative of cos of u is, we have did the substitution u equals 3x or 3x equals u. So therefore this become negative cos of 3x over 3, plus this becomes e raised to the power of t. We did the substitution 2x plus 1 equals t. So therefore this becomes, we can write this as e raised to the power of 2x plus 1 over 2, plus the integration constant c. So this is the result of the given integral.